Hello everyone, my name is Jyotishwar Reddy. Today I am discussing about the final project of deep learning with big data. Here we coming to the introduction. This final project deals with the application of convolutional neural network CNNs in image classification tasks. In this project, we built, train, and tested CNN models with CIFAR10 dataset with TensorFlow as the primary tool without using any keras. We are analyzed various factors that affects the accuracy of model for CIFAR10 dataset and trying to improvise it. Coming to the part one, how using TensorFlow directly in the coding. Uh, Here we go. Like here we have TensorFlow directly in coding, like build, train, and test CNN. Yes, we can require TensorFlow in the final project as given final project overview. Uh, coming to coming to the part two, like we have mentioned, like a data set of images or audio files. We need to search from the internet or Google to approach data set in public domain available without any restrictions. Here we have some important notes, like it's we can select the data set from Kaggle or another websites. We can coming to the part two, data set of images or audio files. I have selected weather data set. I have taken from the Kaggle. The dataset is appropriately labeled and ready for use in deep learning. Ready for use in deep learning research. The dataset contains 6862 photos of various weather conditions that can be classified into 11 classes. Examples: dew, fog, smoke, hail, lightning, rainbow, etc. Coming to slide, here we can observe some pictures of weather image data sets like dew, snow, rainbow, forest, etc. Coming to part 3, obtains if our send data set. Uh, we have instructions for these, like professor has mentioned that we need to download all the data sets which have mentioned in the canvas module and download all the dataset files available there, and we need to access that remote virtual machine in the we need to access all the data files of the database in remote virtual machine and open the subfolder like jpntbk in the remote virtual machine. Create a subfolder under jpntbk and name it as c10 data and upload all the files that are under the C410 from the student's local computer. Here we have, this is the one we need to do for the part 3. And I have here we have like C410 dataset is downloaded from the Canvas module datasets, and I have mentioned all these, and I have created a folder as JP NTBK. In this dataset downloaded, these are the files which we have kept in the next. Coming to part 4, in this we are like we need to in part 4 we need to build, train, and test CNN on CIFAR10 data sets. In this we have some, like we need Jupyter notebook document as DLTF CNN CIFAR10 dataset final project. We got some important information in this. We are doing like design the convolutional neural networks and build, train, and test the convolutional neural networks on the CIFAR10 dataset using TensorFlow, AI frameworks, and Python. Here we have trained the new network with 5000 steps. Test the network after every 100 steps of training. This is the instructions we got for the part 4. Uh, in this part, we have did, This is the design of CNN model for build, train, and test CNN on CIFAR 10 dataset. In this, we have taken input as image, and we have the we have sizes of the image in this, like batch size and image shape. Here we have 100, 32, 3. This is the image shape. 100 is batch size, and image 32, 32, 3 is the image shape. In this, we are in the first layer, we are doing convolution with RLU. In this, after doing first convolution, there is no difference in the size. Like we are applying filter 64 in this coding. Like here, we are giving the metadata, batch all the datas in this. Here we are giving like shape. Here we are giving 332, 32, and there is no clarity in this image because this is 32 into 32 image, and we have some images we don't click clearly properly in these metabolic images. The size is very low, so that's why we are not able to see that images. Now we are here, we have mentioned 332, 32 in this one, and now we are calling CIFAR and helper setup. In this, we are giving the input as in first if build here we are building, reshaping the input in convolution layer 1 output. We are giving shape as 33364. Uh, After that, next we are doing pooling layer 1. Next, after pooling with the filter 64, we are applying. After pooling layer 1, there is a change in the image shape, and it reduced half, like 32 half, and it comes to 16. And now the batch size is same 100, and image size will be 16, 16, 64. Next, after that, we are applying again convolution layer 2. Then there is no, when we apply convolution, there is no any change in the image size or batch size. The image size and batch size is same. After that, again we are doing pooling layer 2. Pooling layer 2, when we do pooling, there is change in image size, image shape. In this, after doing second time, the image size is batch size is same, and the image size is reduced to half of the layer 1, and now it comes to 8864 in the pooling size 2. Here we can observe in the code, like we have mentioned in second convolution layer with pooling con convolution layer, we are applying filter shape 3364, and pooling layer 2 output max pool. And we are in this, we are getting the accuracy in 6984. The max is on the step 4700, we are getting 70. And but final on the final step, on step 4900, we are getting the accuracy level of 69%. And here we have, next we have, after the second pooling, we have flattened the layer, and the image size is the image batch size is 100, and the image shape is 88 into 64. In this, it is for 4096. In this fully concentrated, fully connected, we are taking only 1024, and remaining we are deleted as null. In this is the image shape and batch size. Then we are drop out remaining 3000, and the fully connected to. In the fully connected to, we are taking the batch size same 100, and we are taking image size only 10 output classes in this CNN mode. Here we have built and trained test CNN on CIFAR dataset. The testing of CNN model in CIFAR dataset yield promising results with the accuracy reaching 70% after 4,700 training steps. And we have at 4,900 we got 69.8. Further optimization and fine tuning of the CNN model could potentially improve its performance on the CIFAR 10 dataset. The CNN model demonstrate the ability to learn and classify images effectively, which is crucial for tasks such as image recognition and classification. Coming to part 5, compare CNN network performance. Here we in the part 5 we need to compare CNN performance, and we need to in this accuracy levels we need to compare the CNN with miniset dataset that we have already worked in the homework for. Professor has mentioned we need to compare with the CIFAR and compare the miniset dataset and CIFAR 10 dataset. This results comparing two datasets, and here we can observe the miniset. Here we can observe the improvised one. It's CIFAR 10 dataset and miniset dataset. Uh, In this, we are comparing the convolutional neural network performance. Performance on CIFAR-10 dataset. The CNN model trained on the CIFAR-10 dataset achieves a maximum accuracy of around 99.11% after 4,900 training steps. The accuracy starts relatively low at around 13.49%, but gradually increase with training steps. On the performance of miniset dataset, the CNN model trained on the miniset dataset achieves a maximum accuracy of around 70.16 after 4,000 training steps, 4,700 training steps. The accuracy also starts low at around 10.07%, but improves steadily with training steps. In this comparison, there is a quite gap between two results. The following might be reasons for these two CNNs. Dataset complexity. Dataset complexity. In the Sifferton dataset contains color images of objects belong to different classes of 10 different classes, and whereas the miniset dataset contains of grayscale images or handwritten digits from 0 to 9, which are simpler compared to Sifferton data images. Sifferton data images. In this, we have image complexity. The image complexity uh, defines that image in the Sifferton datasets are more complex and varied, containing different objects in the natural scenes with variation in color, texture, and background. Whereas the images in the miniset datasets are simpler, consisting of only handwritten digits of plain background, that is 0 to 9. In the comparison, we finally conclude that the convolution neural network performance, while both dataset present classification process, the CIFAR 10 dataset is inherently more challenging due to its complexity and variability. Comparing to the miniset dataset, The performance gap between the two CNN models can be attributed in differences in dataset complexity and image complexity, model design, and training time. Here we can observe the accuracy level. This is the accuracy for the mini set dataset. The accuracy at 4900 step is 7094. Uh, after we have we need to improve convolutional neural network. In the part 6 we need to improve convolutional neural network performance. If we need in this in the part 6 we need to improve this CNN network performance by making the changes in the network and training process as processed in the coding. And we can build, train, and test the updated convolution neural networks on the CIFAR10 dataset using TensorFlow frameworks. Yeah, yeah. In We need to improve this CNN performance. According to the results in the section 4 and 5, the complex structure of the dataset input images may be the reason for the previous CNN models. That is low accuracy on the CIFAR10 dataset, adding additional convolution layers and to current models in one way to improve performance and address the issues. This is the design of improvised CNN model. Like here we are adding one extra convolution layer and pooling layer for this previous CNN model. In this we are like same. First we are taking the input of image, the same batch size and image size. After the first convolution layer, first pooling, the sizes are these. And after we are doing second convolution layer 2, and pooling layer 2. Here are images, batch sizes, and everything is same as we are observed in the CNN model previously in part 4. And now we are adding additional layer for this old CNN design. And now we are adding one extra convolution layer 3, that is uh, here is the batch size 100 and image size is 864. By applying filter 64 we are doing pooling 3 with layer 3. In this pooling 3 in layer 3 we are reduced to half of the pooling 2 value and the half of the image shape. Now the image shape is like batch size is 100, the image shape is 464. This is the additional layer which we added the for the new design for the old CNN. And in this we are next we can flatten this layer. After that additional layer adding in this design, we can flatten the layer, and the batch size is 100 and image size is 4 into 4 into 64, that is 1024. We have no need to remove any neurons in this, like we can call it as neurons. We no need to remove any neurons because in previous one we have removed some 3000 neurons. From 4000 we have taken 1024. In this we, after the flattening, we are getting 1024. In this we are fully connected, and now we got batch size 100 and image shape is 1024. Now we have drop out to this and fully connected to, we are now again we are fully connected to. In this we are taking only 10 output classes from this design as previously shown in the previous design of CNN model. This is the improvised design of CNN model. In this improvement, we have many observations. Like in additional convolution layer, we have an improvement in the performance of CNN model in C14 dataset and compare the results. Some of these observations are increased accuracy, steady improvement, and consistency. In this, the accuracy of the model has generally improved across all training steps. The model achieves maximum accuracy around 70.94 after 4,900 training steps, which is higher than the previous maximum accuracy of around 70.16. Here we can observe the accuracy of improvised one, and 4,900 step we got 70.94, and steady improvement. The accuracy shows a steady increase with training steps, indicating that the additional convolution layer has helped the model more complex features and patterns from the images. Consistency. The accuracy. The accuracy values appears the relatively consistent and do not fluctuate significantly, suggesting that the model with the additional convolution layer is more stable and robust. Here we can observe there is like can observe in the observation on 100 we have 3000, 300 we have 45 and 400. There is a slight increase in this. There is no any fluctuations. Mm, and at final we got 1794. Here we have slight steady increase in the observation accuracy. And coming to the previous one, this is the improvised one. Coming to the old one, old CNN, there is like in the observation there is a fluctuations. Like here we got 6,069%, and again we got 70, and again it's got 68, and again we got 69, and there is a low and ups and downs in these results. In the accuracy there is like in we got 70 in 4,700, and it came finally on the step 4,900, accuracy is 69%. So slightly fluctuations in this. After improvised, we have steady increase, and the observation is good. So that's why in this observation we have observed that improvised one adding additional one layer is more stable and robust. This is the overall view. Like additional of extra convolution layer has contributed the performance of CNN model and C14 dataset, resulting higher accuracy and improving learning capabilities. But there is no significant increase since there is only one convolution layer added. Experimentation with different hyperparameters, model architectures, and training strategies may lead to better accuracy and generalization capabilities. Finally, we have concluded from this, like the project provided me with some valuable insights, provided me the valuable insights into the advantages and limitations of CNNs for image recognition task. Through hands-on experiment with TensorFlow, I have learned many train and test CNN models and build better models to improve their accuracy. I can improvise with many new adding new layers, and we can improvise the try and build CNN dataset. I have learned importance of dataset characteristics, model architectures. Here, this is the coding part in the Python we have used for this mini set data type and C14 data type. The images we can see, but that is not clear, so that we can because this is size of the image is 36 into 36. Actually, our size is like, and Coming to the final project report, we have done the report. Here is the report, like part 4. In the part 4, the test results I have observed in the accuracy. I have mentioned all the accuracies on every step which we have observed. The accuracy levels produced by CNN with C14 dataset. This is the compare convolution neural networks, and in this performance of many set dataset achieves maximum accuracy of around 70.16 after 4,700 training steps. This is, in conclusion, we have observed. This is the final project report. This is the final project report. The final report deals with the application of CNN's image classification task. We build, train, and test CNN models with the Cifatan dataset with TensorFlow as the primary tool without using any keras. In the part 4, we have created a CNN model and classified images for Cifatan dataset. And we have built a CNN architecture to classify images into 10 different categories. The model demonstrated good accuracy with increased training steps. It achieved a maximum accuracy of 70.16% after 4,700 steps. In the part 5, I have tested my CNN model on C14 dataset and miniset dataset produce high accuracy of 99% after 4,900 steps, whereas C14 achieved a good accuracy at 70% after 4,700 steps. This is due to higher dataset complexity. Image complexity on C14 dataset, the highlight dataset complexity or model complexity as factors influence performance. In the part 6, I tried to improve the CNN model using C14 dataset by adding an additional layer, convolution layer. In this, it leads to the slight improvement in accuracy, achieving a maximum of 70.94 after 4,900 training steps. The results have led to a more stable and robust model, but also indicated the need of further experimentation with hyperparameters of and model architecture for performance improvement. In conclusion, the project provided me with some valuable insights into the advantages and CNN of image recognition tasks through hands-on experiment with TensorFlow. I learned how to train and test the CNN models and build better models to improve their accuracy. I learned important of dataset characteristics, model architectures, and this project not only helped me theoretical knowledge but also improved my practical skills in applying deep learning techniques to real world complex problems. This is a conclusion. Thank you.